Okay, so we're going to talk about something called the winding filament theory, okay? And the winding filament theory is like the sliding filament theory, but maybe a better way to look at it is a modification to help us better understand what's going on. Okay, so our two objectives for this lecture are to summarize the winding filament theory and talk about how it's different or similar to the sliding filament theory. Now, just because it's been a little while, potentially, since we've talked about this or since you've thought about this, let's go through the sliding filament theory. So we've got calcium binds to troponin, causes tropomyosin to move, actin and myosin bind, ATP binds to myosin, causing actin and myosin to separate, ATP breaks down, myosin head cocks, phosphate leaves, power stroke, ADP leaves, actin and myosin bind, and we start all over again as long as there's calcium, ATP, that sort of thing, okay? And so this goes over and over, and ultimately we're causing actin to go towards the M line. But that's probably not exactly how it works. Now, if you remember from the last video, we talked about the stretch shortening cycle, and we talked about titin, how it's a spring and it can store energy. And we've talked in the past about how titin's a structural protein. Well, it is, but it's also a contractile protein. Okay, now it's a structural protein in that it connects myosin to the Z discs, and it's a spring. Okay, and so when we stretch out a muscle, it's what helps get the muscle back to its resting length, but it does a lot more than that as well. Okay, and so titin is actually not a single spring, but it's a double spring. All right, and it appears, like it says here, calcium activates titin, and what happens is titin wraps around actin, okay? And what happens when we do this is that actin rotates, which produces torque. And we talked about torque about a week ago, and torque is just a rotational force, okay? And so as we rotate this actin, that produces torque. And this is also able to be done. We haven't talked about this, but if you look at it's hard to see, they're really small, but the myosin filaments have heads that are all around them, and so there are myosin heads all over the place, which help play into this rotation. Okay, and so what happens is, as the muscle shortens, that potential energy increases. Okay, and so we're increasing that stored energy, kind of similar to the stretch shortening cycle. And so once we start to lengthen the muscle, well, this stored energy is released. We're able to produce greater force, and this causes a greater or stronger eccentric contraction. Remember, we can resist more force during an eccentric contraction than we can produce during a concentric contraction. Okay, so we're going to talk more about this in class, but I just at least want to introduce this to you here on these videos.